Okay, so in the last example, we had some formulas and we looked at derivatives and second derivatives and slopes being positive and negative and so on. And in this problem, I really like this kind of problem because it asks you to show me that same kind of understanding, but without having to worry about the formulas. So just looking at the original graph and, again, is it curving or is it going up or down? So this problem shows us a graph and we're supposed to fill in the chart at the points A, B, C, and D and be able to answer at those points whether the original function is positive or negative or zero, whether the first derivative is positive, negative, or zero, and then finally whether the second derivative is positive, negative, or zero. So first derivative, no derivative, just the first function, the original function, we should look at whether or not it's above or below the x-axis. So it's as simple as that. So above, below, or I guess on the x-axis. And I like to be able to restate each of these without having to use the word positive or negative because each part is asking positive or negative, but different things are positive or negative. So if I can restate it as I've done, just saying above or below the x-axis, that'll keep me from being confused. Okay, so point A is below the x-axis, so f is negative. Point B is above the x-axis, and so f is positive. Point C is also above, and point D is below. So I guess I didn't make up a good example. None of them were on the x-axis. Okay, let's shift gears, and I like to use that language again to remind you now I should be thinking about something different. So now, for f prime, I'm not going to ask ever, is it above or below? It's the wrong way to look at it. I should ask the slope. Is the slope positive or negative or zero? Another way to put this is the graph going up or down or flat? And that's fine, but just again, don't think about the y values. Don't think about is it above or below. Okay, so at point A, it looks to me like the slope is 0. At point B, again, it looks like the slope is 0. And remember, when I say slope, if you wonder, what does that mean? It's a curve. It's the slope of a tangent line. And so what I'm doing is I'm drawing like a little piece of the tangent line, and that helps me see it more clearly. Okay, point C, that's a line going down, and so that's negative. Oh, I forgot to write my answer for B. B was 0, C was negative. And point D, that's a line going up. It's actually rather steep. So if I was trying to graph what the derivative looked like, I would have a positive value there, but it'd be pretty high up. Okay, so the slopes are recorded. And then last, I want to talk about the concavity, which way it's curving, and so on. And remember, concave up rhymes with a cup, and concave down rhymes with a frown. And the only thing I'm going to add to that is sometimes you might just see part of a cup. It doesn't have to be the whole cup, like it could be the left half or the right half. And the same thing with the frown. It doesn't have to be the whole frown. Although in this particular function, it is pretty much the whole part in the original graph anyway. Okay, so at part A, I have a cup shape. There it is. And so the second derivative is positive. In point B, I have a frown shape, and so the second derivative is negative. Point C is actually still on the frown, I would say. So I would say C is also negative. And point D is on a cup. It's on the side of the cup, and so I would say that's positive. One thing I could think of that would be nice to add to this example is some places where it looks like maybe the second derivative is 0. And that's actually, it's harder to see. Let me highlight them just in case it comes up on another problem. And actually, let me change colors back. The way I do this is I look at the clear places that I've already highlighted in pink, where it's clearly up and it's clearly down and clearly up again. So that's at points A, B, and D. But then in between, somewhere in between is where it changes. And so I asked myself, well, how far could I extend these pink lines to where I'm not sure anymore? And somewhere in between is where it must change. Okay, so just showing you real roughly, looks to me like maybe it changes concavity at the spots I just circled in green. And so that's where it would be, the second derivative would be 0. I don't really know what goes on at the very end, so I wouldn't say anything there. Maybe it keeps curving, maybe not, I can't tell. But at least at these two middle places, it looks to me like the second derivative would be 0. It's not super precise where that happens, but somewhere in there. And so if I'd labeled points on the graph and put them in the chart down below, roughly where I've got these green circles, then I would say at those points I would have answered the second derivative was 0.